Bismillahirrahmanirrahim. Assalamu alaikum. So we are discussing combination of functions. That means to combine two functions or more than two functions to create new functions. Previously we have seen that from sum of two functions we create a new function. From difference of two functions we create a new function. From product we create a new function, and from quotient we create a new function. Now we're gonna see another interesting way of creating a new function out of two functions. So this is what we call composition of two functions. Composition of two functions. First we will see rough idea, and then we will define officially what do we mean by that. Let's start talking about it. Suppose you are having three sets. One is set A and the other is set B, and let's say we have got another set which is C. Now let me say that I have got a function f which is defined from A to B. Okay, let's say I have got a function g which is defined from A to B. So you can give name f or g, it's up to you. So what will this function do? It will take elements from A and will throw them to B. Suppose we have got another function, that is function g, and what g is doing, it's taking elements from B and throwing them to C. So it's taking element from B and throwing them to C. We are interested in finding out a function which directly takes element from A and throw them to C, and this can be achieved by defining the composition of these two functions. So if this is g, then this should be f. I had to give one function named f. So let's say this is f, this is g, and this is f. So we want to define a function which directly takes element from A and throw them to C. So A to C, we need a function, and this can be achieved by defining the composition of two functions. So what we can define is we can compose this g into f. So this is going to be f of g. That means g is composed inside f. This is a function. How to evaluate this on any element x? So you will substitute your g into f. Next thing is, when this composition is defined, or when we can define this, when or under what conditions is composition defined. So you can see one thing. Suppose g is taking an element from here and it is throwing it here. Now what will f do? It will pick this element and will throw it here. The question is, can f always pick this element? The answer is no. If this element is out of the domain of this f, then f cannot pick this element and throw to C. So in order to fulfill this element has to be in the domain of f. So in other words, you can say that the range of this g, I'm defining it R of g, when it is contained in the domain of f, subset of domain of f, then we can define it. Okay, so the function which is composed inside another function should have domain which is contained in, should have range which is contained in the domain. So you can say that this is inner function and this is outer function. So you can say that the domain or range of inner function should be subset of domain of outer function. So this terminology is from our side, that f of g means So this is inner function and this is outer function. So when this composition is defined, it is defined when the range of this inner function is subset of the domain of the outer function. So next question. So let's do some of the examples of composition of functions. Let's say we are given with a function f of x which is equal to x plus 2 and another function g of x which is 4 minus x square. Then we could ask multiple questions. One can ask what is f of g, second can be asked what is g of f, and third we can ask what is f of g at, let's say, x equal to minus 2, and fourth one can also be asked what is g of f at x equal to, let's say, 3. So we can ask these questions. By the way, I haven't mentioned it, now let me mention it, that f of g and g of f are not always equal. These are not always equal. We will talk about them later on as well. So let's get started with first one. So f of g operating onto x will be f of g of x. Means you have to compose or you have to insert g of x into f of x. So this g of x will be replaced here at x. So g of x plus 2. Then g of x is 4 minus x square plus 2. So you will get 6 minus x square. So this is the composition f of g. Now we can answer this 3. So f of g at x equal to minus 2. So you just need to put minus 2 wherever it is x. So 6 minus minus 2 is square. So 6 minus 4, which is 2. By the way, you can also do it in another way. That is going to be, so you can first compute g of minus 2 and whatever the answer is, put it into f. So what is g of minus 2? You substitute minus 2 here, so you will get g of minus 2 is 0. So then you put this 0 into this f, you will again get 2. Then we have got g of f in the second part, g of f. So where g of f operating onto x can be given by g of f of x. So now you will put f in f of x into g of x. So it is going to be 4 minus x square will be replaced by f of x square. 4 minus, you will put the value of f of x which was x plus 2 squared. So 4 minus x square plus 4x plus 4, which can be written as 4 minus x square minus 4x minus 4, which can be simplified to get minus x square minus 4x. Then we were asked to find out what is g of f of 3, let's say. So you just need to put 3 in place of x. So you will get minus 3 square minus 4 times minus, plus 3. So this is going to be minus 10 minus 12, which is minus 21. I hope that makes good sense to you. Next tricky part is to talk about the domain of f of g, how to find this domain. So this is really some tricky logically how to find. So this domain of fg, so don't forget that g is inner function. Let's say it is defined from a to b and f is defined from b to c. So this f is outer function and g is inner function, which is composed inside f. So you, in the domain of f of g, you will take those values of x. So those values of x, those values of x from domain of g, g of x, let's say. So you will take those values from a, or the domain of g, for which for which g of x is in the domain of f of x. So that's really tricky into the words. You will find those x values for which g of x is in the domain of f of x. So you can say that, so let's say this is a function g which is defined from this set a to b, and let's say you have an f which is defined from b to c this way. So you will take those values of those x values from this domain of a for which this element g of x is in the domain here of f. So whatever the domain of f is, g of x should be into that. So it can't be the case that you have an x for which g of x is going out of the domain of f. If that's happening, then you can't take it into the domain of f of g. Let me explain it in the better way. Let's say you have an element here. So these are three sets a, b and c. Let's say g is taking this element here. Suppose f which is defined from b to c has this domain. Now this element is out of this domain of f, so we can't take it into the domain of f of g. So this element is not part of the domain of f of g. I can take an example. Let's say our f of x is x square minus 9, and suppose the g of x is square root of 9 minus x square. Now first we want to define the composition f of g. So this is very easy to define. So it is going to be f g composed into it. So it is going to be g of x square minus 9, which is going to be 9 minus x square whole square minus 9, which is going to be simply minus x square if I'm not wrong. About the domains, domain of f of g, where g was equal to 9 minus x square and f was equal to x square minus 9. Don't forget that this is inner function which is defined from a to some b subsets of R, and f was defined from, let's say, b to c. Now let's say this is my set A and this is my set B and this is my set C. So this is set A, this is set B, and this is set C. You can see the domain of f is all real numbers, so it is all of the elements here. So you can say that this is all the real numbers, so everything here. And the domain of g is minus 3 to 3. You can find out the domain of g. Now I can take those elements from this domain for which this g of x is in the domain of f, but this domain of f is this whole set, so every element that we will take from this domain will be into the domain of f. So because this whole set is filled with the domain of f, so any element that is coming from here will automatically be in the domain of f. So in that case you can say that this every element here is going to be in the domain of f of g. So the domain of f of g is equal to minus 3 to 3. So you can say that if in case because we are in the real numbers, if the domain of this outer function is equal to all real numbers, means the domain of this outer function is all real numbers, then domain of f of g is simply equal to domain of inner function. Yeah, you might disagree and you might comment if you don't like that, but that is how it is going to be.
If you have liked the video, then press the like button and leave your kind feedback. For more mathematical content and calculus content, please subscribe our channel CalculusCraze and press the bell icon.